Hello and welcome to the Unknown IITians channel. And today we're revising week 1. So in this video, we'll cover everything that needs to be known for week 1. So not anything extra. And after this, we'll probably be able to solve the graded assignment. And you can also move on to the week 2 or anything. But this is basically everything you need to know. So let's do it. Let's get started. So first we're doing flowcharts. And before you do flowcharts, let me explain a little terminologies related to computational thinking and flowcharts that we'll be using repeatedly. So the first thing is, what is an algorithm? Now, in case you don't know, an algorithm is a set of instructions that needs to be followed to complete a particular task, right? So this set of instructions could be anything. Any instruction for you to do a task. For example, you look up a recipe online, and it says step 1, add this to your bowl. Step 2, add that. So that list of steps is an algorithm basically. But here we are defining algorithm for a computer. So a list of steps for a computer to follow and use in order to complete a task. So that is why we need an algorithm, and that is why we program an algorithm in different ways so that a computer can understand. So that is what computational thinking is about, for a computer to understand your algorithm. Okay, now what a flowchart is. So a flowchart is a graphical representation of an algorithm. In simple terms, the algorithm is written like a graph. So a graph as in it's like step 1 and then a line representing the next step, then step 2, then step 3 and so on. So that is how you write a flowchart. So, and another term is iteration. So iteration is like when you repeat a bunch of steps in a particular set of data. So iteration or iterating something is going through a sequence of objects and performing the same operation on each of the objects. So for example, if there's a bunch of people and I tell you to count the number of people, so you're gonna count each of them one by one, and every time you're adding a number to your count. So for example, you count the first person and you say 1, and the second person and you say 2, and then the third person and you say 3, and so on. So you're repeating the same step on each person. So that basically is iteration. And if you don't understand this right now, then you'll get used to it as we go through the course and through the flowcharts and everything. So let's move on to the flowcharts now. So let's define a few objects we need to use in the flowchart. So these are a few tools. So this box you see right here, this is process or activity. That is a set of operation that change the value of data or variables. So it could, as I said, when you're counting, you're counting like the first person as 1. So you can write the count is first 1, then it changes to 2, then it changes to 3. So that's how you're counting, right? So this count is a variable because it keeps changing. So this process or activity box is used for defining variables for things that keep changing. And the second one, that is this arrow or flow line, this is shows the order of execution of the program steps. So as I told you, it's going to be step 1 and the next step 2. So this arrow here represents the order of the steps. And then we move on to the next one, that is decision box, determines which path the program will take. So this usually contains a question. So the question could either be yes or no, or true or false. So suppose this side is yes, and there's going to be some step over here for after yes, and then there's going to be no here, then something after no. So that is how it's used. And the next is terminal. This is used for start or end, just for start or end. So just the starting part and just the ending part, that's it. Now, as we use it, we're going to use it into the flowchart as we move on. So we have a flowchart here for counting the number of cards in a pile. Okay, so we have a pile. So first we arrange the count is equals to 0. This box is the terminal, and this box is the processor activity box. So here we initialize the count to 0. That is, we put all the cards in pile 1. And then this is the decision box. So see, this contains a question that can either be yes or no. So the question is, are there more cards in pile 1? So if it's a no, then it's going to end. If it's a yes, then it's going to continue from here. So these steps are the iteration, because these steps will be repeated on every card we use. So pick a card X from pile 1, move X to pile 2, increment count. So here what we're doing is this pile 1 and this pile 2. Every time we pick a card and move here, the count becomes count plus 1. The term increment is used for addition, because it's adding a number to the count every time a card is counted. So at the end of the execution, this count variable will contain the number of cards present in the pile 2. Okay, so this ends when there's no cards in pile 1. So when this pile becomes empty and the count variable contains all the number of cards in this pile, then this comes to an end. So these are the steps. The first step is initializing. Then unvisited are there. We check if there is any unvisited element. Yes for true. Then pick an unvisited element, mark element as visited, and update the variable. So this is what we're doing in this flowchart here. So let's see another example. So here it says girl sum and boy sum. So this is for the scores dataset. If you haven't seen the dataset, I suggest go through it, because we're gonna use it a lot, even in the questions and everything. In this course data set, if you know, there's a name of a person and there's a gender, another information like this city and date of birth, and there's marks for each subject. There's math marks, there's physics marks, and chemistry marks, and there's a total marks at the end. So that is how the scores data set is like. So here we're counting the math marks for both girls and boys. So we initiate the sum as 0. This is initiated to 0 every time we start a new data. Okay. So this is initialized to 0. So the first step is checking whether there's more card in pile 1, that is the decision box. If yes, we pick a card from pile 1, move X to pile 2. If X is a boy, then add card X marks to boy sum. If this box is false, if the gender thing comes false, then it's obviously going to be a girl. So we add the score to the girl sum. Now here, these steps right here are your iteration. This is initialization, and this is to check if there's any unvisited element. So if there isn't any unvisited element, then this question box becomes false, and that is when this process ends. But it doesn't end here, because if this becomes false, then it goes to this step. So it's not like every time the decision box comes, there's going to be an end of the process. It can be moving on to another step as well. So I hope you understand what a flowchart is like. We won't get any flowchart based questions, but there's going to be flowchart written as steps. So the flowchart would be like, step 1, put all the cards to pile 1. Step 2, are there any more cards in pile? Check if there's any more cards in pile 1. Step 3, pick X from pile 1. Step 4, move X to pile 2. There's going to be something like this, and then they're going to ask you a question like, what does count represent at the end of the execution? Or what does A or B or anything, any variable represent, or what will be the value at the end of the execution? So they're going to ask you questions like this. So step 1 will also always be initializing. So this can either be count, this initializing part can either be count or sum of something or something else. So this will always be step 1, initializing the thing, initializing the variable. And then this will be step 2, to check if there's more unvisited elements. Then this will be step 3, then this will be step 4, and this will be step 5. And after this, there's going to be a statement. There's going to be a step 6. Wait, let me just. There's going to be step 6 which says move to step 3, move to step 2. Sorry, it's going to be moved to step 2 here. And then this is going to be the step 7. So it's going to say move to step 6, from step 6, move to step 2 if this iteration is completed. And it's going to be if there are any more cards in pile 1, then move to step 3. If not, then move to step 7. So this is how it's going to be written in steps, and they're going to ask you questions based on that. So that is all about flowcharts. Now let's move on to the types of data. So there's majorly 3 types of data, that is Boolean, character, and integer. So the Boolean data type, it can only have a true or a false value, and the operation is and or, and the result type is also Boolean. So the result is also going to be either true or false, or either yes or no. And a lot of times we code true as 1 and false as 0. So either 1 or 0, or true and false, or anything like that, only 2 values. Now, in the case of integers, as you know, integers is basically numbers. So it can be any integer from minus infinity to plus infinity. So any integer in between can contain that value, and we can perform mathematical operations on these integers, and the result type we get is also an integer. So for example, we take a number 3 plus 7. So plus is a mathematical operation, and the result we get is 10, which is also an integer. And there's another operation we can perform on these is the comparison operations. So that is either greater than or less than or equal to. In this case, the result type is Boolean. So the result is Boolean. So like suppose there's a statement like the marks of student A is greater than the marks of student B. So this is my statement. Now the statement can either be true or false. Suppose student A got like 60 marks and student B got 90 marks. So in that case, the statement becomes false. So the result type in over here is Boolean. Similarly, for equal to, so the same statement can be changed to the marks of student A is equals to marks of student B. So even in that case, you can the statement can either be true or false. So yeah, the result type is again Boolean. And for character, it can be alphanumeric. It can contain any character from A, B, C, D, or 0, 1, 2, 3. Now you say 0, 1, 2, 3 is an integer. So how does it come into character? Integer. For integer, the difference is you can perform mathematical operations on integer, but for a character, you cannot do that. So let's say the roll number of students, you cannot add to students' roll number and be like, and that data won't have any meaning. So you cannot perform mathematical operation on something like serial number. So in that case, the thing becomes a character, and this thing contains numbers from 0, 1, 2, because negative numbers usually don't have any meaning in counting or serial numbers or anything. So it's usually positive numbers, and it also includes special characters, and the only operation that can be performed is equal to. So for example, checking if the names of 2 students are equal, or the date of birth of two students are equal. So that is the only thing that can be performed, and the result is Boolean because it can either be equal, or it can either or not be equal. So either this or that, so either true or false. So that gives a Boolean data type as a result. And this can contain a string character. Inside character, it can contain a string of values. Now what is a string? String, or you can say a sequence of characters. So anything like names of people, that's not going to be just one character. For example, for serial number, it's just going to be one character, number 1, number 2, number 3. But for names, it's going to be multiple characters, a bunch of characters combined together to make a name. So that is for string. That a bunch of characters or a sequence of characters is called string. And we can take some examples for integers. Examples like marks of students, or the count of student, number of students, anything that can be, even dates can be integers. Now for Boolean data type, the operation are and or. Now let me tell you how these operations work. So for and operation, it should be true. Both the statements should be true. So let's say something like, so the statement is the student should be male and the student should be from Chennai. So male and from Chennai. So both the statements should be true if there's an and operator. So if you get a card and the student is a male, then this becomes true. But then if the student is from somewhere else, let's say the student is from Mumbai, then this statement becomes false. Then this entire statement is considered false because this part becomes false and there's an and operator. So like in English we use and, right? So this and that. So both should be true in order for the entire statement to be true. Now similarly, if there was an or operator in between, there was an or operator. So if the student is male, but let's say the student is not from Chennai, then this statement becomes true because for or either this or that should be true. So one should be true, one should be false. You can also take like you got a female student card, but the student is from Chennai. So this statement is true in that case, and this statement is false. This still is true because one of the statement is true, right? So that's all we need for or operator. So here for or operator, one statement should be true and the other statement should be false. And then similarly, there's one more operator, that is the not operator. So for not, if there's a not operator and there's some statement. So if this statement is false, if the statement isn't true, if the statement is false, but there's a not operator in front of it, so this becomes true. So like not of false is true and even not of true is false. So let's take an example. Let's take the same example. So to check if the card is male, l- let's say the card picked is actually a male student. So then the statement becomes true. The statement inside this operation becomes true, but not of true is false. So if there's a not operation in front of the statement, then this entire thing becomes false. And similarly, the card picked is of a female, then the statement inside this operation is false, but not of false is true. So this operation makes it true. That is how it works. If you don't understand it right now, then you don't have to worry about it because as we go through the pseudocodes and all this, you'll actually you'll actually see how it works, so you'll understand it better there. Just know how it works right now. You don't have to memorize it. Just see how it works. That's it. And then next is sanity of data. Here they have taken the words data set. So in case you haven't seen the words data set, then it's taken from a sentence. There's like a word in the center and there's a part of speech here and there's a letter count. That is the number of letters in the word here. And there's a serial number on the top or the card number. So this is how the word data set is like. So the card number is is a character. So it can be any character from A, B, C or 1, 2, 3 because it's a serial number. So the card number can be A, B, C. The word here is a string. String again, as I told you, is a sequence of characters. So the word includes for a word unpleasant, there's multiple characters inside this word itself. So this is a string. Then the part of speech is also a string. So this is an adjective in this case. Now for the letter count is an integer here, but since it's a count, it can only have values from 0 to infinity. You cannot count in negative. You can only count 0, 1, 2, 3. So it can have values from 0 to infinity. So for sanity of data, we have to check if all the data is the way it's supposed to be. So count is not supposed to be negative. So here the sanity of data is not maintained because this count is negative. The letter count could be 10 but not negative 10. So similarly, let's say for an integer, if the value is given something like ABC or a random name, then the sanity of data is not maintained in this case because integer can only be numbers, right? So let's say if the value is like 1, 2, and 3, then here the sanity is maintained because, of course, it's an integer. So that's all about the sanity of data. The sanity is like The data should basically be same. So yeah, the data should be correct. The data should be where it's supposed to be, not anything additional. And lastly, thanks for watching. And make sure you watch the next week as well because we'll be moving on to pseudocode, I guess, the next week. But yeah, that's all you need to know for this week. And the questions will be easy. The steps would be given to you, and then they'll ask, what is the count? What's the count at the end or something? Or maybe questions based on data types. But it's easy. And if you've watched this video, if you've understood this video well, then you'll be easily able to do it. It's not that hard, don't worry. And make sure you watch the next one as well. So thank you and have a nice day.